Now we will add one of the systems that triggers the alarm in our game, the CCTV cameras that are trying to spot the player. The first step is to drag the model into the scene and position it on the battle bus. In the Models folder, locate prop_CCTV cam. It should look like this. Drag it into the hierarchy and then position it at -8, 3, 16.1. This will place it on the battle bus, but it needs rotating by 180 in the y-axis. Select it in the hierarchy and with your mouse cursor over the scene view, press F to focus on it. Make sure to check the Use Light Probes box on the mesh renderer on each of the game objects in the camera hierarchy, so that the camera has dynamic light shining on it. As you can see, it's now properly lit. Light probes have been set up for you and are part of the lights prefab that we created earlier. The next thing our CCTV camera needs is a frustum. We want to start by adding the collision mesh to the camera. When the player is detected within this frustum, the alarm will sound. We want to start by adding the collision mesh to the camera. We need to make it a child of the camera body. In the Models folder, locate prop_CCTV cam collision. Drag and drop this onto prop_CCTV cam body in the hierarchy. We need to reposition it slightly. The frustum should appear to be coming from the lens. Set the position of this object to 0, 0.15, 0.35. The purpose of this game object is to show where the camera is pointing and to detect the player when he's in front of the camera. To physically detect the player, we're going to use a trigger collider. Add a mesh collider to the collision object that we just added. Click the Add Component button and choose Physics, Mesh Collider. Then check the box for Is Trigger. The frustum looks a little poor at the moment, so instead we're going to use a spotlight to show where the camera is pointing and remove the unnecessary visual components from the game object. Remove the mesh filter by clicking on the cog to the right of it and choose Remove Component. Do the same for the mesh renderer. Before we create any visual effects, we want the camera to be pointing in the right direction. We want to prevent the player from passing through this space when the camera is facing forward, so to completely cover the area, we're going to tilt the camera body 60 degrees in the x-axis. Select Prop CCTV Cam Body, and in the x-axis for rotation, put in 60 degrees. To visually represent the frustum, we're going to add a spotlight to it. Reselect Prop CCTV Cam Collision, then go to Add Component, Rendering, Light. Change the type to Spot. Set the range to 9.5, the angle to 90, the color to red. We'll set the shadow type to Hard Shadows with a bias of 0.02. We don't want this light baked in if we rebake the light map later, so we need to set the light mapping setting to real time only. This looks okay, but to improve the effect, we're going to add a cookie to the light. A cookie is effectively a texture that your light projects. The one we're going to use is in the Textures folder and is called FX Camera View ALP. Drag and drop this on to the cookie property of the light. And you should see a star-like pattern projected on the floor. Now we need to make a script to report the location of the player when he's spotted by the CCTV camera. We'll call it CCTV Player Detection. Click the Add Component button and choose New Script and name it CCTV Player Detection. Click Create and Add and then double-click the icon to launch it for editing. Remove the default functions and set up your script for use. For this script, we'll need a couple of private class variables to store references. Firstly to the player, so that we know it's the player that we've detected. Secondly, we need a reference to the last player sighting script on the game controller, so that we can update the position variable when we need to. We'll now use the awake function to allocate these references. We can allocate the player reference using FindGameObject with tag and pass in the player variable from our tag script. We can also find the game controller in the same way. We then need to use getComponent afterwards to get a reference to the last player sighting script on the game controller. Now we're going to use onTriggerStay to detect the player. Given that a collider will be detected within the trigger zone, we want to check if the game object belonging to that collider is the player. We need to be careful at this point. It could be that our player is on the other side of a wall, but still intersecting the collider. To resolve this, we're going to raycast from the lens of the camera to the player to check the line of sight. We'll start by finding the relative position of the player from the camera, so that we have a direction to raycast in. We will also need a raycast hit variable to determine whether or not the raycast intersects the player collider. Using these, we can raycast from the camera towards the player and get back information on what the raycast hits. Next, we need to check whether the game object of the collider of whatever we hit was the player. If it was, then we want to update the game controller with the last sighting of the player. This concludes the CCTV player detection script, so we need to save it and return to the editor. At this point, we want to drag our CCTV camera into the prefabs folder to save it as a prefab. We can then duplicate this around our level to make more cameras. Select the parent prop CCTV cam and drop it onto the prefabs folder in the project panel. Now let's duplicate this camera twice for our other cameras in the scene. We now have 3 in the same place. Let's position one of them at -21, 2.2, 2. Then reselect it in the hierarchy and press F to focus on it. You should see that this is now on one of the buildings in the lower left of the game. Now select one of the other CCTV cams and place it at -23, 1.8, 24. Reselect it in the hierarchy and press F with your mouse over the scene view to focus on it. You should see that it's now on the wall of the security department building in the center of the map. This camera needs to spot the player coming through the break in the fence, so we will tilt it up in the x-axis in order to face the fence. Drill down into this object and select Prop CCTV Cam Body and set the rotation of X from 60 to 30. Select Prop CCTV Cam Collision. We also need to lengthen the trigger collider so that it reaches the fence. So change the scale to 1, 1, 1.8. We want the camera on the battle bus to be animated, so we will return to working on this camera now. Reselect it and focus on it. We want the camera on the battle bus to be animated, but before we do this, we can notice that the intensity of the spotlight is not enough. This is the power of prefabs in Unity. Because we now want to update all 3 cameras with a brighter intensity, we can drill down into any one of them, select Prop CCTV Cam Collision, and change the intensity. Set it to a value of 4 and press Return. Then hit the Apply button. This saves the change out to the prefab, and now when we check our other CCTV cams, we can see that they have a brighter intensity too. Now let's animate our camera. This camera should sweep back and forth. We do this by creating a new animation asset. Select the Animations folder in the project panel. Click the Create button and choose Animation. Call the animation CCTV Sweep. Now expand the Prop CCTV camera and select Prop CCTV Cam Joint. Drag and drop this animation asset onto the object in the inspector. This adds an animation component and assigns this asset as the animation to play. Now we need to open up Unity's animation window. Go to Window, Animation. We'll dock this along with our game view at the bottom. This allows us to see the animation we're doing in the scene view and work on the animation at the same time. We want the camera to rotate around the y-axis, so we will click on rotation.y and select Add Curves. To the right of rotation.y, click and choose Add Curves from the menu that appears. This will add rotations as curves on the graph and give us a keyframe at the start of the animation. We want the animation to last about 2 seconds, so we will add another keyframe there. Scrub the playhead to 2 seconds, and click the Add Keyframe button at the top of the animation window. Now set the value to 60. All that's left to do is to make sure that our animation loops. We do this by changing the wrap mode at the bottom, which is currently set to default. Change this to ping pong. This means that our animation will go from 0 to 60 and then head back to 0 in an infinite loop. This completes the creation of our animation, and we can test it by pressing the play button at the top of the interface. You should note that when our camera is rotated, there is a gap around which the player can sneak. This concludes the creation of our CCTV cameras and the end of this assignment. In the next assignment, we'll look at creating laser gates, which are designed to detect the player also. Remember to save your scene and save the project before moving on.